So today we're going to take a look at continuing really our discussion of polynomial equations, and we're going to encounter maybe an unlikely culprit at this point in the discussion, but it leads to what happens next. So we're going to talk about the Pythagorean Theorem. The Pythagorean Theorem is actually an application of the distance formula. I talked about it briefly when we talked about section 2.1. It finds the application of the distance formula because it finds the distance or the length of the line segment between two vertices of a right triangle. If A and B are legs of the right triangle, and C is the hypotenuse, which is the side opposite the 90-degree angle, then A squared plus B squared equals C squared. So you've seen the Pythagorean Theorem many times at this point in math classes. Sometimes in geometry, sometimes in algebra. It keeps kind of popping its head back up because it's related to both. The biggest thing to make sure when you're working with the Pythagorean Theorem is that you correctly identify the hypotenuse. And that hinges upon knowing where your 90-degree angle is. So we'll want to be careful about that. Other than that, A and B are interchangeable. Doesn't matter which leg you use as which. Doesn't matter if it's the longer or the shorter or anything like that. All that matters really is the hypotenuse. So as we take a look at some triangles, the first thing to decide when we're looking at a particular triangle is where the 90-degree angle is. And I know you see it, we just don't always take the moment to sort of recognize it, so be careful on that. Of course, the 90-degree angle in this triangle right here is here, right? That's my 90-degree angle. What that means is that the x in this triangle is my hypotenuse. So the hypotenuse is always on the side alone, right? So the hypotenuse piece will be this piece that's squared and alone. So in this particular triangle, it is the x squared that is alone. And then the other two pieces that I'm going to use are going to be the squared pieces that are added. And it doesn't matter in what order. So I'm going to write down 9 squared plus 40 squared. Now, we've talked about it before, but order of operations matters. Don't go adding the 9 and the 40 together. You've got to square them first, right? Exponents happen before we add things together. So what is 9 squared? 81. It's actually also a game that kids play. Do you guys know 9 squared? Yes. I guess some of you are saying no. It's like 4 square, but better. It's like they put the poles up and they hit the ball over it. Some sort of a combination of 4 square and volleyball. It's a lot of fun. The kids enjoy it. We have a set at our church. All right, how about 40 squared? What's that?
Is that an Oklahoma thing?
I don't really know. Does anybody know? Is it an Oklahoma thing?
They played it in Texas.
Okay, we had an experience in Kansas a couple years ago where they had a 9 square set up too. So maybe it's a Midwest thing. It's possible. I don't know. All right, 40 squared. Sorry, totally off topic.
1600.
1600 is it? You bet. All right. So we have the 81 and we have the 1600. We'll add them together, so I have 1681. Most of the time, the directions will say to keep our answers exact. Sometimes it's irrelevant because it's a beautiful number such as this and it works out nicely. It's always a good thing to try. Just see what happens when you take the square root. We want to have the square root of this. It might be a perfect square root. This one is. So if you take, and I don't have my calculator with me today, unfortunately, but if you take the square root of 1681, what do you get? You get 41. So this one actually worked out very nicely. If you had gotten a decimal and they wanted an exact answer, which they often will, the directions will explicitly tell you do not round or something like that. So if that's the case, we're going to need to factor something, right? So you're going to have to take 1681 and you're going to have to break things down. This one actually worked out very nicely, so there's no need to break things down because it's a perfect square. That doesn't always happen, but it did here. Okay, so looking at number 2, again, the first thing to do is to make sure that we identify the right angle. Where is the right angle in this triangle? At the top, yeah. So it's right here, which means this side opposite it is my hypotenuse. So on this one, my hypotenuse is actually the 12 that will be by itself. The other two pieces will be squared and added. So that gives me the x, so I have x squared. And it gives me the 6, so I have 6 squared. So again, order of operations. So what is 6 squared? 36. How about 12 squared? 144. And then as I'm working with solving equations, I need to move the 36 to the other side. Subtraction, that's right. So we'll subtract the 36. What's 144 minus 36? What is it? 108. So just in case you're curious, 108 is not a perfect square. It just isn't. Feel free to grab your calculator just so you can see. Take a square root so we can actually put down both answers because you could be asked for either. What is the approximation that it will give you? We'll go to around to 2 decimals. 10.39. So if we want a decimal approximation, this is not a perfect square, but it's 10.39. If we want to find an exact answer, we would factor, right? So what would divide 108? 2, or even 4 will, because of the 8 at the end. So I'm going to go with something just a little bit bigger, so hopefully we can get to the pieces at the bottom sooner. It would be a 4 and what? 27. Lovely.
Do you want us to put an exact answer?
It'll tell you. You won't have to guess. I promise it will tell you. So 4 would be 2 and 2. Then 27, well, we'll do it that way. 27 is 9 and 3. And then 9 is 3 and 3. So as we've seen before with square roots, we're looking for pairs of things because it's a square root, right? The index is a 2. So there's a pair of 2's and a pair of 3's. So the 2 would come out and the 3 would come out. I'll just write it over here since I'm out of space at the bottom. And I would be left with the lonesome 3 underneath. Sorry, my screen is a mess. And then I have my 2 times 3 is my 6. Generally speaking, though, Caden, the default is exact answers unless something tells you to round. But I'm pretty sure on a lot of ours we're going to have directions. This one says round to the nearest hundredth. Sometimes they do. Hundredth is 2 decimal places. Oftentimes they don't tell you to do that. They'll ask you to keep your answer exact. So 2 different kinds of answers depending on what the directions ask. This one did ask for rounding. All right. So this actually leads into something called the square root principle. It happened in that last example. At some point, it actually happened in both of the examples. At some point, we ended up with x squared alone on a side and another number on the other side, right? So if we have x squared alone on the side, one side and the other number, whatever it is, alone on the other side, we have the square root principle in effect. So x squared equals a constant k. Then if k is less than 0, right, if k were negative, there would be no real number solution, right? Square root of a negative number, that's not in the definition of square roots, okay, not for real numbers. It is, and we will talk about it with imaginary units later, but that's not today's discussion. We're still working with real numbers. Number 2, the option is that the k value is greater than 0. And truly, it could say greater than or equal to 0. It's just not very exciting if it's equal to 0. So if it's greater than or equal to 0, you can take the square root of both sides, and it's a defined operation. And that's exactly what happened in our last 2 cases, right? We had the case where we put the square root on there. Now, you might notice, well, but this says I'm supposed to put plus or minus k, right? Square root of k. Why did I not need to do that over here? Any ideas?
Because you're finding the distance.
Yeah, because on this side it was actually the length of a side of a triangle, right? It actually had context that made the negative not make sense. You know, I can't have a negative distance. I can't have a negative length. In general, in a problem, we could have a negative value, right? That'd be a possibility. So when we're putting a square root into the problem and there's not context that excludes the possibility, we will put a plus or a minus on our values. So for example, we'll do the next one so you can see it happening. We have x squared equals 98. So when that happens and we take our square root, we will in fact put plus or minus at the beginning. And because it doesn't indicate anything about rounding on this one, right, we are going to keep things exact. And we're going to break it down like I did with the 108 to show you before. 98. What will 98 divide by? So at the very least, you should know it's even. Yes? So if you can't go any further, you should know it divides by 2. What does 98 divide by 2? What does it give you?
49.
49. Okay. Good. 2's prime, but 49's not. What will 49 divide by? 7 and 7. So at this point, I've got all my primes down here, right? And I'm doing square roots, so I'm looking for pairs. There's a pair of 7's. So in its exact form, one of those 7's comes out. The 2 that's alone stays underneath the radical. Let me shift this over just a little bit. So I have positive or negative 7 square root 2. What does that really mean? Well, it really means there's two solutions. It means there's a 7 square root 2 solution, and it means there's a negative 7 square root 2 solution. You don't have to write that out, but that's what plus or minus means. It means I have two solutions, one's positive and one's negative. So this is fine to recognize that, but that is what's happening in that problem. How about on number 4? What happens on number 4 if I try to take a square root?
You get 6.
Do you?
Oh, are you talking about the negative?
Mm-hmm.
Oh, I just kind of moved plus or minus.
Yeah, so there's a negative on this one, right? That's something different. It's actually quite different. It puts us in the first case over here. If I have this equal to a negative number, right, x squared is equal to a negative number, this has no solution. So you can say D and E for does not exist. You could write down no solution for me. There's even one more thing you could write down. Some of you have been told not to do this all the way along. You can do a 0 with a line through it. That's what no solutions notation is. So any of those are perfectly acceptable answers to this. Why? Why does 6 not work? So let me actually just show you. If you had the 6 times 6 would be 36, not negative 36. And if you had negative 6 times negative 6, you'd also get 36. There aren't two numbers in the real number system such that when I multiply them together, I get negative 36, if the numbers have to match. Do you have a question, Cameron?
Yeah, why on number 3 it was negative 7 square root 2?
It's not. There's two solutions, 7 square root of 2 and negative 7 square root of 2.
So when we put the answer in, it was correct.
But you can write it like this, where you have the plus or minus in front, or you could write it where there's two solutions either way.
Okay.
Yep, your choice. The most condensed, maybe easiest way to write it is the first one. But if you want to write it out, you could. And the reason that that works, of course, is because if you multiplied 7 square root 2 times 7 square root 2, or if you multiplied negative 7 square root 2 times negative 7 square root 2, both of them will yield 98. In this case, you have a positive already. In this case, you've got a negative times a negative, so there's your positive. The 7 times 7 is 49, and the square root times square root 2 is 2. So you get back to the 98 you had before.
So whenever there's a negative, it's just...
Yeah, you actually should be like really excited when you see the x squared is equal to something negative, because it means you don't have to do any work, as long as you recognize it, right? So be aware. If it's got x squared equals a negative number, the answer is just no solution, and you're done. Okay, let's try another one. Now 5 looks a little different, and for whatever reason 6 is not written in your notebook, but we're going to do a number 6 as well. So number 5 has something squared, but it's not just x, right? And it's actually not even on the same, like by itself on the side. But it can be manipulated to do the same thing that we just did on the last two problems. So the first thing I'm going to do is that negative 32, I'm going to move it to the other side. Okay? So the first thing I want to do is I want to get the squaring part alone. So I want to leave the w minus 8 squared on the left, and it now is equal to 32 on the right. Is that good so far? I just shifted a number. I'm allowed to do that. I can add a number to both sides. Now, while it may look like I don't have x squared, if I blocked this out, right, big old yellow blob squared, right? What would I do to solve for the big old yellow blob? I'd square root, right? It doesn't matter what's inside the blob. It doesn't matter what's inside those parentheses. So we're going to square root both sides. When I do square root both sides, the square and the square root cancel, just like they did when I square rooted the x squared. But I'm not just left with w, I'm left with w minus 8. We'll come back to that in a moment. The 32 has to be factored like we did before. So somebody tell me how a 32 could factor. 8 and 4, fabulous. 8 can be 4 and 2. And 4 is a couple of 2's, just like this other 2. 4 is a couple of 2's. So you actually have a bunch of 2's, right? That's what 32 is. It's 5 2's. Pairing things up, right? So here's a pair, and here's a pair, and then I have a loner. So the 2 pairs come out. The loner stays underneath. And I put the square root on, so I need to put a plus or a minus in front. Okay, so far so good. Did several things in that step, all at the same time. So I've got my plus or minus in front. 2 times 2 is 4. So I have 4 square root 2. On the left, I have w minus 8. Now, my goal is to solve for w. So what do I have to do with the negative 8? I need to add it to the other side. Now, about 5 of you are going to be really tempted to say that this is now going to be something like 12 square root 2. Okay, that 8 cannot combine with the 4 square root 2. They're not like terms. 8 doesn't have a square root of 2 attached to it like the 4 does. So the only thing we can do is simply write it in front, or it could be written in behind if you want, of the plus or the minus. So again, what this really means is that I have 8 plus 4 square root 2, and I have 8 minus 4 square root 2. Those are my 2 solutions to the problem. And in its condensed form, it looks like 8 plus or minus 4 square root 2. And I can't combine it. There's nothing I can do to write this any simpler than these versions. Those are my only options. No combinations. We're going to try one more of these here in just a second. Is that okay? Now, this happened because when I took my square root of the 32, I was left with a piece that still had a radical in it, right? That doesn't always happen. Sometimes we'll take square roots of things that are very nice, like that 1681 at the beginning, right? Where it ended up being a perfect square root of 41. And that's actually what's going to happen on number 6 as well. Sorry that number 6 got left out of your notes, I think, or did it? Do you have it's out, left out, or it's in?
It's not.
It's not in. Okay, so take a second to write it down. This is problem 6. Okay, so thinking about what we just did on the previous problem, what would be my first step? Add the 25. You bet. So we're going to add 25. So I have w plus 9 squared on the left, and I have 25 on the right. Then what? Square root. But something nice happens on this particular square root, at least from all outward appearances, it seems nice. What happened?
5.
It's a perfect square, right? Now, we need to be careful, and I wasn't when I wrote mine in. I didn't leave enough room. This is plus or minus the square root of 25, right? So the square root of 25 is 5 with a plus or minus in front. And then my square here cancel, leaving me with w plus 9. Okay, so far so good? Great. Now again, I need to subtract the 9 just like on the previous problem. And I can actually combine the 9 and the 5 on this one, but we need to be careful. You can't just combine the 9 and the 5 because you don't have 5. You have positive 5 and negative 5. So in a very real sense, we need to separate them on this one in a way that we didn't have to separate them on this one. Like I wrote this out for you and I said, oh, you could do this, right? But you don't really have to. You could leave it in the condensed form and all is well and you're done. But you don't have that luxury on this problem because they combine. You have to separate them out. So this will end up being 9 plus 5 and 9 minus 5. Because I have, negative 9. I apologize. These are both negative 9s. I have to take this negative 9 and I have to take the plus or minus the 5 that's there. I have 2 options. So there's 2 choices. Another way you could sort of separate it out is at this point if you wanted to. You could write out that this is w plus 9 equals 5 and w plus 9 equals negative 5. So if it helps you to separate them out one step earlier, that's fine. It doesn't matter. But it does not become plus or minus 14 or plus or minus 4. It doesn't come out that way. I have two separate answers, and they're not the same thing with a plus or minus in front. What is negative 9 plus 5? That's my negative 4. And what is negative 9 minus 5? That's negative 14. So I don't have plus or minus 4 or plus or minus 14. I actually end up getting two answers. One of them is negative 4 and one of them is negative 14. So I have to do the combination, right? So remember before I just said it seems like this was really nice, that the square root of 25 was perfect. But it actually meant you had more simplification to do than before.
Anytime we have a perfect square, we'll have 4 answers correct.
You don't have 4 answers, you have 2 answers. Yeah. So you'll have to separate it out into 2 separate pieces, though. You will have to separate it if you have a perfect square. Yeah. So perfect squares, while nice, end up creating more work in the end because you have to simplify things you didn't have to simplify before. All right. Have you seen the quadratic formula before? Yes, I see some nodding of heads. That's great. So the quadratic formula actually takes something that's in what would be considered quadratic form, ax squared plus bx plus c equals 0, and it finds a solution by using the coefficients a, b, and c directly into an equation. It's nice in some sense because it always works. Doesn't matter what the a, b, and c are, you can use it. So factoring's great when it works, but you've probably all had a class somewhere where you had to factor something and you tried everything you could think of, and then some teacher said, haha, it doesn't factor. You know what I'm talking about, don't you? It's really annoying because things don't always factor. They just don't always work that way. But the quadratic formula always works. So that's nice. The quadratic formula requires memorization. So you've probably been asked to memorize it before. I'm going to ask you to memorize it as well. It's not a terribly difficult one to memorize, but you can do it. So at this point, if you're making a list, and I would encourage you to do so, there's been a few things that I've asked you that you're going to have to memorize. The distance formula, that was one. And the midpoint formula, yes. And now we have the quadratic formula. And if you don't know the Pythagorean Theorem, I suppose that's probably one you should have memorized as well, although it's pretty straightforward. I think you probably know it. So I'm going to sing for you. Are you ready? I know. Quadratic formula, it just begs for a song. Have you heard it? No. Have you heard Pop Goes the Weasel? Okay, it's the tune of Pop Goes the Weasel. It goes like this. It says, x equals negative b plus or minus radical b squared minus 4ac all over 2a. Yeah, it's exciting. It's the only time you're going to hear me sing. Now you can remember it, right? That's a mnemonic device. Okay, so we're going to utilize the utilize the quadratic formula to solve one next. I'm not going to sing it again. But you're welcome to go back and listen to the video, and you can hear it many times if you would like. Okay, so you need to memorize this. I don't care what it takes for you to memorize it. You can do it. Okay, so just write it on a note card, look at it every, couple of days or whatever until we get to the test. You'll have it done. No problem. So here's the equation we're going to start with. The thing that you need to recognize is that all of this is hinged upon the fact that it's set equal to 0. So no matter what the formula looks like that's given to you, you have to adjust it so that everything's on the same side to start. Don't go starting before you do that. So on this one, it doesn't have equals 0 already, which means we have to take a step back and do that first. So the first thing we're going to do is we're going to move the 1 on the left-hand side with what's there. So I have 9x squared plus 4x minus 1 equals 0. Okay, it's not a terribly difficult thing to do, but it will mess it up if you have the wrong sign. And that's what you'll do. You'll have the wrong sign if you're not being careful about having it set up properly to begin with. So each of the variables, a, b, and c, in the quadratic formula, whoops, I meant to go backwards, come from the coefficients of these terms. The a term, oh, that's a typo. Man, that should say ax squared. If it's not written in your notes correctly, please make sure it is, because that needs to be fixed. The a is the term before the x squared. The b is the term before the x, and the c is the constant at the end. Okay? So the first thing to do, once we get it into the right form, is to identify correctly A, B, and C. So our A is 9, our B is 4, and our C is -1. Sorry, that got away from me. -1. Okay? So hopefully you can see that if I had forgotten perhaps to move the C, I might inadvertently think C is +1. And a negative will change things inside of your formula very quickly. So we're going to come over here. We're going to take a look at finding x equals. So it's -b. So it's negative or the opposite of whatever b is. Our b is 4. And so you're going to see me put a parenthesis around each, the a, the b, and the c as I put them in, just to be careful that I don't lose a sign somewhere along the way. It's easy to do. So x equals -b plus or minus the square root of b, which is 4 squared, minus 4 times a, which is 9, times c, which is -1. All over 2 times a, which is 9. So anytime you're working with a quadratic formula, you should have a step that I can see that has all these numbers in the right locations. And the reason that that's really important is because if you simply put a number in the wrong location, I don't want to take off the entire points of the problem. But if I don't know where the mistake happened, it's really hard to know if you're doing pieces of it right. So show me the pieces all put into place so that I can make sure that it's not the arithmetic that's going wrong, it's just a placement of a number or vice versa. Okay, so we can figure out what's going wrong. My son is in a class right now, and he is working on some fraction stuff. And I got a note from his teacher that he doesn't understand anything of what he's doing. And I'm like, great, right? So I get the paper home, and it has nothing to do with fractions. His misconception is not a fraction misconception. Well, that's helpful to know, right? Because that's what I was thinking. He's got a fraction issue. His issue is adding and subtracting integers, right? And I could see that very quickly because I saw his work and I saw what he was making the mistake on. It's so much easier to provide you helpful feedback if I can figure out what it is you're doing wrong. Same for the grader. So make sure you're showing me some work along the way so we can identify any errors that are happening. So here's a -4 at the beginning now. I don't necessarily need to keep the signs separate from the parentheses. I don't need that, right? Because there was not another negative inside. Plus or minus, and I'm going to do a little bit of simplification along the way, just worked out. 4 squared is 16. Yep. And then I have all of this. So I have a -4, a +9, and a -1. What does that give me? 36, and it's positive, right, Zion? Yes. So I have 2 negatives, so I'm going to get a +36. And then we're going to divide that by 18. Okay, so far so good? Okay, order of operations, I'm working inside the radical to combine the pieces I can first. What is 16 plus 36? It is 52. All right. I know that there's a 4 and there's an 18, and you're probably saying, hey, they're both even, and they are. But in order to divide anything, you have to divide it by all 3 pieces. And by the pieces, I mean the pieces that are all separated with the additions and subtractions. Right now, the square root 52 doesn't have anything in front of it that's even. It has actually just the number 1 in front. I need to simplify the square root of 52 using the things that we've done with radicals before I can look to see if I can reduce anything. So at this point, I'm looking at the square root of 52, and can it be reduced? So it can, right? What will 52 divide by? 13 and 4. And again, if you don't see those 2 at the beginning, that's fine. You can at least see it's even. And 4 is 2 and 2. So I have 2 2s. That's a pair. So I've got my -4. I can bring out a 2, and the 13's alone, so it gets left underneath. I've got it divided by 18. Okay, is that step okay? Changed my square root 52 into 2 square root 13. At this point, I do have those 3 separate terms, and they do have pieces that are even. I've got this one, and this one. They're all even, right? So I can reduce them all by dividing them all by 2. So -4 divided by 2 is -2. The plus or minus 2 divided by 2 would be 1. If you want to leave that written as a 1, you can. If you just want to not write it, because 1 times square root of 13 is square root of 13, that's fine too. Don't care whether the 1's there or whether it's missing. And then it would be divided by 9. Even if that 9 on the bottom had been even, let's say that that's divided out and we ended up with, say, an 8 on bottom, there would be no more reducing I could do. Because even though an even number on bottom would divide by the 2, there is no even number in front of the radical 13 on top to continue dividing. You would be stopped at this point because there's a 1 in front of the square root of 13. Person?
What if the 13 and 2 are switched? Could you still divide it? Or does the number that could be divided have to be on the outside of the radical?
The number that's divided has to be on the outside of the radical. Yes. So you're always looking at the location here, here, and here. Okay, so the number has to be between the positive and negative and the radical piece. It has to be right there. Good question. Any other questions? Simplifying that radical expression right here is usually the place where there's the most mistakes with quadratic formula, is knowing when I can and I can't simplify something right here. Okay. Also, it's probably worth noting, let's say, for instance, that when we had done the simplification that gave me the 52, I'd gotten something negative. Right? Let's say it ended up being negative 52. Well, if that happened, at this point, the answer is simply no solution. It's no solution, because I don't have the square root of negative numbers. All right? We'll talk about them later, but right now that's not what we're working with. We're working with a real number system, and we don't have square roots of negatives. Okay? So if you do get something that has a square root of negative inside of the radical, double check, make sure you don't have a sign error, right, that's producing that. But if you've done everything right and you still have a negative underneath the radical, you can stop right there, simply say no solution, and your problem is over. All right.